Hi, welcome to the ICP course, standing for Introduction to Chemical Processes. This slide is for introducing this course. My name is Hyun-Kon from School of Energy and Chemical Engineering, UNIST, Korea. Here is the syllabus or course information. Code number is ACE212, the first class. And title is, as I said before, Introduction to Chemical Processes. I'd like to say ICP, standing for Introduction Chemical Processes from now on. And the class, the weekday and the time period and the building number and the room number. So grading, of course, I will use the letter grading system including A, B, C, D, F with plus and minus or 0. 6 absences is indicating just F without any evaluations. Your activity of this class is graded by 100% examination, 50% from midterm, 50% from final, and also you have an extra 10% point, which comes from assignment plus attendance. Textbook, this one, and the ICP, again, Introduction Chemical Processes, is designed for students who are in the chemical engineering major. This class focuses on 2 aspects. The first aspect is about the qualitative one, and the second one is the quantitative one. The first one is what chemical processes are as a qualitative aspect of chemical engineering. Plus, the second thing, how to analyze and design the processes as a quantitative aspect of chemical engineering. Here's some keywords of this course: material balance or energy balance, plus thermodynamics, plus basic information on units and dimensions will be covered in this course. Okay, so I have said about my office. No. Okay, so you can reach me at this office, the building number and also room number. Also, you can contact me via telephone or sometimes homepage or my email. Your teaching assistant or TA will be announced on your Blackboard system. Okay, so here is the schedule of your course. In this table, you can find the week, like first week, second week, and up to 16 week. And in the second column, period, like March the first week, March the second week, sometimes the 5th week of this course have March 5th week plus April 1st week. And then in the third column, you can find some content of this class. This course includes 1 introduction section and 6 chapters. The first one is reaction. Second, process. Third, material balance. The fourth item is reactors here. And then separators. As the final chapters, you will learn about the energy balance equations. Also, please check the schedules on your calendar in terms of examination. Here is the midterm examination schedule already fixed and final examination schedule already fixed. Okay, so I'd like to give you a brief idea about the chemical engineering, or actually this course of introduction to chemical processes. Reaction is the core concept or core item of this course. Here, reaction formula here, A plus B reactant is going to C, which is the product. So let me try to make this kind of the product C. In the lab scale, in a beaker, you can use it. And then pour A and B as reactant. And then you will mix together. Sometimes you require some temperature, like 100 Celsius degree or something like that. Then after some time later, you will get the product C. Or sometimes you'd have the remaining reactant A and B. This is the process. The process includes some reaction plus operations. In this case, operations include mixing together by using magnetic stirring bar plus some heating apparatus. So process is defined as the chemical conversion as specified conditions achieved by intended operations. So reaction is a really important thing. But sometimes you would not have the reactions. For example, separators. There are no reactions. In this process, you will try to separate the desired product C from the mixture of C and B and A. That is the separation process. However, the reactor is more important thing. Here is some pictures representing three representative reactors. The first one is so-called batch reactor, which is very similar to this situation. So it is called batch reactor. So it looks like a beaker. Into the batch reactor, you will pour every reactant into the reactor and then close the door or close the cap and then wait for like 2 hours. Then get all of content inside of the reactor. That is the batch reactor. Let's go to the second one. It is called CSTR, and C stands for continuous. And S means stirred. This is T. Stirred. Mixing. And then T, tank. Looks like tank. Reactor. So, the shape of this tank reactor is very similar to the batch reactor, but the different thing is on the pipe. During the reaction or operations, reactant A is introduced continuously. Also, B is introduced continuously. And then also, upstream is continuously going out of the chamber. So you will get the C. There are big difference between batch and CSTR because, you don't have any continuous inlet flow or outlet flow in the batch reactor, but you have them in the CSTR. The third one is so-called PFR. This is the plug, PLUG, and flow. It looks like a pipe which is surrounded by some heat jacket. So you can hold some temperature like 400K, 500K or something like that. And then some the reactants are introduced into inlet of the pipe. And then along the pipe, A and B are reacted to each other. Along the pipe, I'd like to emphasize along the pipe. So at the very inlet position, you have just reactant. However, at the end of the position of pipe, you can find a lot of the product C. So you can get some product C here. This is similar to the CSTR in terms of continuous operation. The batch reactor is on the non-continuous operation. Those are three representative reactors. Okay, so how many equations are required for calculating something related to chemical processes? How many? A lot of? I don't think so. What we need is only two balance equations plus two equilibrium equations. The first balance equation is material balance equations. Material balance equation. Sometimes you could use mass balance equation. Sometimes you could use mole balance equations. It looks like a lot of equation, but it's very simple. In minus out plus generation is accumulation. So it's very based on the common sense. Everything is like that. In minus out plus generation is accumulation. So that is the material balance equation. The second one is energy balance equations. Also the same thing. In minus out plus generation is equal to accumulation in terms of energy instead of materials. So we have two equations here, and the other two equations includes reaction equilibrium and phase equilibrium. If you have a log, your reactant is 100% converted to the product, like A plus B is going to C, and at the exit of CSTR, what you can find the only thing is C. It is a really good situation, but actually impossible. Usually in the exit of the reactors, you have a mixture of A and B and C. Why? Because the reaction conversion is limited by reaction equilibrium. Actually, reaction equilibrium is the equilibrium constant, Ka. You would be very accustomed to this concept, product per reactant, the ratio of product per reactant. So you will use the equilibrium constant for some calculations. The other thing is phase equilibrium. Here's some example. Raoult's law, Henry's law, very simple equations. Sometimes it can be more complicated, but anyway, you have learned about this very simple equation related to phase equilibrium in your high school chemistry, or at least freshman chemistry in university. So again, we need to have only four equations, which contains two balance equations and two equilibrium equations. That's all. Okay, I'd like to give you some definitions related to processes. Okay, you don't need to memorize them. at this point. You will learn about that in the main body of the each chapter. But anyway, just with a fresh mind, just shape the parameters. For the reactor, we'll try to define some conversion and selectivity and yield. Those parameters are related to describe how well the reaction goes. Also, how many the product is generated from the reaction. The second process is separator. So we will try to separate the product C from the mixture of A and B and C. So of course, fractional recovery or separation factor, almost similar ones, would be very important to describe the separator. And splitter, actually splitter is very similar to the separator, with a very tiny difference. Then also we need to have some parameters to define the performance of a splitter, like fractional split. You will learn about that later. Okay, those are the keywords and contents of ICP, Introduction to Chemical Processes. It's time to say about what the chemical engineering is. Chemical engineering, let me change to raise a pointer. Chemical engineering is the engineering for chemical conversion processes. And the chemical conversion processes are the processes of converting raw materials or chemicals into more useful or valuable forms. In other words, we will convert cheaper raw materials into more expensive products. Then we'll get the money. This is the industry to make some money. Who are chemical engineers? The chemical engineers are the engineers to apply physical science and life science by the help of mathematics to chemical conversion processes. So we are using various principles like chemistry, physics, or biology and biochemistry. At the same time, we'll use the mathematics as the methodology to design the processes. Chemical engineers, sometimes so-called process engineers. Practically, process engineers design, construct, and operate plants. Okay, let me compare between the chemists and chemical engineers in terms of job statistics. Let's just go to PhD degree. So after getting the PhD degree, chemist is going to the further study at 51% of chemists, like a postdoc or something like that. However, chemical engineers is going to the full-time job at 61%. So we are engineers. Chemist is going to academia at 60%, but chemical engineers is going to industry at 66%. There is some reason. Why? Because the salaries of chemists is around $75,000 in average. However, chemical engineers would get $100,000 in average. So it is the reason why chemical engineers is going to the industries. It means societies want us for industries more than chemists. Actually, this job statistics is coming from Chemical and Engineering News 2012. So maybe the salary is about right now $150,000 for chemical engineers. Actually, it is not very important thing. Okay, let's get back to chemical processes. Products in chemical processes. Chemical processes would produce raw materials like oil, natural gas, air, water, metals, and minerals into more than 70,000 different products. We could classify those a lot of products into four categories. Basic chemicals, the amount of basic chemicals in dollar is about 40%, and including polymers, petrochemicals, inorganic chemicals, and fertilizers. And life science occupy 30% dollar, pharmaceuticals, diagnostics, health products, vitamins, pesticides. Specialty or fine chemicals about 20 to 25%, similar to each other. Electronic chemicals, industrial gases, adhesives, sealants, coatings, and catalysts. Consumer products, just 10%, like soaps, detergent, and cosmetics. Those are the products made from our chemical processes. Could you guess how many chemical companies, how many Korean chemical companies is included in the top 20 chemical companies in the world? Only one Korean company is included, which is LG Chem. Actually, I have worked for LG Chem for 2 years just before joining UNIST. Anyway, here's the top 20, actually top 23 list of the chemical companies. Let me check it. 4 USA companies like Dow Chemical, maybe you have heard about the name. The other thing is DuPont, ExxonMobil Oil Company. I'm not sure about that. And 3 Japanese company, Mitsubishi, and Sumitomo, and Dore. And 3 German company, BASF, the biggest one. Actually, last year, well, I'm not sure, 2 years ago, Dow Chemical is merged into DuPont, or vice versa. So the composite company of Dow Chemical and DuPont would be larger than BASF right now, because this is the data of 2014. Anyway, 3 Japanese companies are included in top 20. And also, I have said, I should say German, BASF, and then Bayer, and aspirin company, and then Linde Group, something like that. So we have only one company in top 20 chemical companies. Okay, that's it. And please enjoy some YouTube video clip to learn what happens in the chemical processes. This clip is about petroleum refining process. Then from the next section, we are going to the body of this class. That's it.